Hello, please let me explain with a simple example why my program FittingKVdm might give you much better results than any other regression analysis program you know. Everybody knows the so-called body mass index. You take your mass in kilograms and divide it by the square of your height in meters. And then you know if you are too fat or too skinny. Now, this square is actually very strange. It's not logical because the mass of a body is proportional to the third power of the size normally. So how did Adolf Kettele 200 years ago find this exponent 2? Actually it was 2 point something, and he knew that something was wrong with it, but anyway he rounded it to 2 exactly, and well, since then we are using this formula for 200 years now, and nobody actually seems to know why. Nobody can explain it. Well, with my new software FittingKVdm, you will see this mystery is solved. Let's look at some data. I have a file here with the heights and the masses of adult men in a good body shape. They're not too skinny, they're not too fat. So you see the measurements here. Vertical is the mass, the horizontal axis is the height. Of course they are not nicely on a line because many factors influence a person's mass, but we will try to find a best fitting model here. We expect that the relationship between mass and height is a power function, so we choose this model function. So we have two parameters. This is a multiplication coefficient, this is the exponent. Now I will first show the traditional fitting method. So this is the first guess, and now we iterate. You see we have a convergence. The exponent becomes 2 point something. I will speed it up a little bit. So you see it stays around 2.1 something, and that is probably why everybody thinks that the mass is proportional to the second power of the height for the last 200 years. Now we have taken the height as the independent variable here and the mass as the dependent. Now there is no reason why we shouldn't switch the two, and we will try and see. Now we would expect the exponent to be about 0.5, of course, because if you switch mass and height we get an exponent of 2 point little bit, so it should now be 0.5 something. Okay, let's try. Now something very, very strange is happening. You see, it's absolutely not 0.5 but 0.2. That is very, very, very weird. there must be something wrong with the way the parameters are estimated, because in both cases exponents are too low, so the curve is too flat. Now, the least squares method, what does it do? It minimizes the sum of the squares of the vertical distances between the points and the line, the measurements and the calculated values. Now, why only the vertical distances? What would happen if we used also the horizontal distances? Well, that's what I implemented in this software program. Let's go back to the first file. So, masses versus heights. And now we will not minimize the sum of the squares of the vertical distances, but sum of the product of the squares of the vertical and horizontal distances. I call this multidirectional fitting. So we switch it on now, and let's iterate. Ups, ups, ups. Aha. What do we see? The exponent becomes 3.15. Now, the exponent is not exactly 3, of course, with these data, but it's a lot closer to the 3 we expect from scaling laws. The most important thing about this multidirectional fitting is, of course, that we now don't have to worry which variable we choose as dependent and independent, because it will always automatically give the same relationship. If we have a third power here, the inverse relationship will be a power of 1/3, or the third root, which makes perfect sense, of course, doesn't it? Now, if we compare the classic model quadratic relationship between mass and height and the cubic model, so instead of 2 there is an exponent of 3, I think it's quite obvious that this line fits much better than this one, and yet all the existing software programs will give you something like this, while my program FittingKVdm will give you this. Of course, this multidirectional fitting method will not only work for power functions, but for all functions where you can calculate vertical and horizontal distances between the measurement and the model function. So it means for all invertible functions you will definitely get better results. If you don't believe me, just try it with your own data. You can download it here and try everything for free for 25 days. And anyway, it's not expensive, only 25 euros if you want to buy it. If you have any questions or remarks or suggestions, please let me know. I will try and answer them, and I hope to see you around. Thank you for listening.